Hello, everyone, and welcome to AWS webinar about Moodle on AWS. So I'm Daniel Bacevic, and I would like to also introduce our speakers today who are joining me on the call. And we have Steven Smith, who is solution architect at AWS, focusing on Moodle, among the other stuff. We will have also Alex James joining us from JISC, who will be together with Mark Woodbury from Rackspace, covering different aspects of technical implementation of Moodle together with Steven. So just to quickly set the stage, the Moodle is estimated to have 80% on average across Europe among learning management systems, and it has the biggest number of users globally, which is based on the Moodle stats now, 269 million. As we go forward and going out of the pandemic, we heard from 90% of our customers speaking about top three issues for their schools and universities, and those three are operational planning, instructional technology development, and student support service capabilities. So today we decided to go for Moodle because of the overall footprint, but also the overall importance of Moodle as a technology or learning technology tool. So without a further ado, I would like to pass the word to Steven, who is going to introduce the first aspect of the webinar. Steven?
Thanks, Daniel. So yeah, hi everybody. My name is Steven Smith, as Daniel says, so I'm a solutions architect here at AWS. Just running through the agenda today. So as I say, Daniel's introduced the team we've got on the call today, so thanks to Alex and Mark for joining us. We're going to run through more of a technical discussion today, so we're going to look through a typical Moodle architecture on AWS and what that might look like. And then what we'll do is talk through each of those different tiers of the web app, if you like, and how Moodle may apply in each area and which AWS services might apply in each area and some considerations around that. And then, yeah, we'll hopefully wrap up and take some questions towards the end and throughout. So we'll move on. So just firstly, I just want to take a minute or so just to set the scene. I appreciate, the audience on this call today is probably already very aware of kind of why you might use AWS for this kind of application. But I just wanted to reiterate really the kind of typical cloud benefits that we hear when we talk about this kind of web app, and certainly in recent times with the need to scale kind of learning environments and those kind of things. The ability to kind of burst out and scale on demand has really kind of come to fruition, I think, and really lent itself to this kind of app. Being able to stop guessing capacity, I think, is a really big one. A lot of our customers need to try and prep for their peak days throughout a year, exam testing times or coursework upload times, those kind of things. And with this, when you run this kind of platform on AWS, you of course only need to scale when you need that, you need it to be there and need it to be provisioned. You don't have to run that headroom all year. And so there's some good cost savings and good cost efficiencies to be had there, as well as operationally it being, significantly simpler. And that really, again, comes on to just my final point here around the increased speed and agility of this kind of platform. So we'll touch on some of this today, but being able to spin up multiple test environments, for example, or just increase your capacity and introduce new web instances or introduce new database instances, depending on the load requirements, is obviously a great benefit and something that a lot of customers really like when they move this kind of app into AWS or when they're running it there in a scalable way. So without further ado then, I'll hand over to Alex to share his screen and we can kind of start talk through the tech discussion. Cool, thank you, Alex. So as you can see on Alex's diagram, this is a typical web application architecture. So, the typical kind of 3-tier with a web and app layer and database tier and different database instances and database types and in-memory and relational and all that good stuff. You'll see on here that we've detailed quite a bit around the networking as well, which is something that Alex will dive into in a bit more detail. And also you'll note on there around the RDS and database instances, we have Aurora listed, which is part of our RDS relational database family. Again, we've got Mark on the line from Rackspace who will dive into that in a bit more detail. So I'll just try and cover kind of top to bottom some design considerations over the next few minutes when it comes to Moodle on this kind of platform anyway. So what we've done here is kind of tried to break it down into what might be public facing and then what you're able to run actually in private networking and private subnets in your VPC on AWS. So making some assumptions here that the audience is kind of broadly aware of public private subnets in AWS and what that might look like in VPC. Obviously, if there's any questions on any of this stuff, please get in touch. But today I want to focus on the different services and how they impact Moodle and any considerations for this kind of application. So you can see on Alex's diagram here as well how we've split it up into multiple availability zones. So on the left we've got availability zone A and on the right availability zone B. And just a quick note and a quick point on that to say that spreading your application or your infrastructure across multiple availability zones in any given AWS region is definitely best practice when it comes to high availability. There's of course use cases where you might want to have everything in a single availability zone, maybe test environments that aren't so critical for high availability and those kind of things. But from a production standpoint, we would always encourage you to design this kind of architecture across multiple availability zones. So if we start at the top then, let's look at, just very quickly talk about Cloudfront. So Cloudfront is our CDN service. So kind of managed CDN service. Like everything with AWS, it's kind of pay as you go, pay for the traffic, pay for the throughput, those kind of things. So it's really flexible and really quick and easy to get started with. When we think about Moodle and specific considerations for Moodle, obviously a lot of the pages and a lot of the content in there are particularly dynamic and don't necessarily lend themselves to being statically stored in kind of a CDN in the typical sense. But there are still things we can do in there, for example, with static assets, so imagery and kind of heavyweight things like that can take its toll a little bit on the downstream platform. So that's great for those kind of things. And also any kind of static pages that are truly static or that are generated and then are common across your user base, for example. That's another good use case. And again, there's of course a lot of different things you can go into there configuration wise to do caching based on different headers and different cookies and get quite complex with the cache key, as it were, and be able to really maximize the performance and the cacheability of your application. So there's a lot to consider when we think about Moodle and caching. It's not always that straightforward, but Cloudfront's a great start and I think a great way to, in the very first instance, at least help with those static assets. If we take a next look down, we then come to a web application firewall. And again, this isn't something that you necessarily need to implement, but we'd always encourage you from a security perspective to take a look at it at least. So with AWS, security is always job zero, and we definitely would like to encourage our customers to think that way as well. Certainly with this kind of platform that's typically public facing to some degree and open to your user base. Web application firewall allows you to do things like block common web exploits like SQL injection attacks, cross-site scripting, those kind of things. And also you can get very specific for specific applications. So if there's a known vulnerability in Moodle or something comes out in the press or whatever it may be, you might be able to kind of block it in there and take action before it becomes an issue for you. So definitely worth looking at that in this kind of architecture. And next step down, so we're kind of getting onto more of the core infrastructure now. So where we start to look at instances and databases and things. But before we get there, the first step and one to really take advantage of here is our elastic load balancing platform. So this allows you to effectively balance traffic across multiple instances, so web instances or web containers or whatever it may be, and we'll come on to that in a second. The beauty of the elastic load balancing family, and in this case, a part of that family you'd probably want to consider is what we call our application load balancer, which is a layer 7 load balancer and allows customers to get quite smart with the way that they direct traffic around. For example, you might want to use it to do blue-green deployments and target different backends based on different versions of your application or different pieces of content in there or something along those lines. So it's really quite flexible and open to those kind of configuration changes. As I say, it's worth mentioning as well that it doesn't just load balance across EC2, it can work for our container services and others as well. So even if you've got not necessarily this exact architecture for Moodle or any of your other apps for that matter, there's a good chance one of the ELB elastic load balancing family will be able to help you out there and balance traffic across your application. And it's also worth mentioning on here as well that these are highly available if they're designed that way. So with elastic load balancing being a managed service, in order for us to provision that managed service in your network and inside your VPC, you effectively need to tell the service which subnets in your VPC to use for the load balancer. And if you give it all of the subnets across all of your availability zones that you've got subnets in, then it's highly available, and you kind of get that assurance that it's going to be highly available should something happen in a single availability zone, for example, or for some of your instances to disappear for some reason in one availability zone. The load balancer obviously will take care of that. So I guess just to kind of talk through then what would be probably more of the traditional infrastructure that you might be running on premises now, or even in AWS with the web and database tier. So you'll note on the diagram here we've got an auto scaling group with multiple Moodle instances in it, just for kind of the purposes of demonstrating here. So the EC2 instances that we've got there are just exactly that. So they're just EC2 instances. Think of them as, for those of you that aren't familiar, as kind of virtual machines. So you design and build an image, or there's images available on our marketplace, or just images that we have pre-published with all the relevant and I guess popular operating systems. And in there you would kind of package in your application, package in your web server, give that to what we call a launch configuration, and then have that run in your auto scaling group, and that'll be the thing that controls, the number of instances that are running at any one time. You can have rules in there that can scale up and down based on demand and based on metrics, and kind of get quite complex and quite clever with the way that you scale. But it doesn't have to be just plain EC2 instances either. We've got customers that will run containers in this space, for example, maybe because they're familiar with they've got a container workflow already and they're familiar with how that works, and they've got a development pipeline that works with containers, and so it makes sense to run containers in this way. The only thing I would caveat here, certainly when it comes to Moodle, is think about any kind of code caching and OP caching PHP. What we wouldn't want to do here is have very ephemeral, kind of fast-moving, fast-rotating instances that don't live for very long, because then you're not getting the benefit of caching at all at the kind of the PHP layer. And so we definitely want to think about at least having some long-running capacity in this layer. I want to say long running, I don't mean for months and years on end, but certainly a good few hours or a couple of days, and then rotate, or depending on your deployment pipeline and how that works, you might want to just roll them out as you do deployments, for example. But it's just worth remembering that caching is a key part of that as well. I guess moving on, and related to that, we need to think about how, because Moodle is one of these apps that requires some kind of shared storage amongst all its web instances. And now typically, if you're running this on premises, that's not necessarily an issue. You've probably got shared storage mounted to the server where Moodle's running, or the couple of servers where Moodle's running. But you can obviously quickly see an issue here, potentially, if we're running a couple of Moodle instances in AWS and then we need to scale to 100 or 1,000. How do we cope with sharing that storage? And this is where one of our other services, EFS, comes in. So EFS is a managed NFS share, in effect. And what this will allow you to do is mount shared directories on all of your instances. There's multiple ways of doing that. Maybe you want to do it at boot time or something along those lines. But what it means is that there can be common directories across all of your instances, and they all see the same directories at very low latency. And so that kind of solves that issue of, I guess, more transient instances coming up and down and needing to see the same storage. So that's kind of where AFS comes in. There's also an option, Moodle specific, with multiple plugins that allow you to use our S3 storage in some cases to do asset storage and asset retrieval and those kind of things. I won't touch on this too much because I know Alex is going to touch on this a little bit, but it's kind of it's the ability to potentially offload some of that storage off of AFS and onto S3, which is a really cost-effective object store in AWS. Again, highly available, one of our more popular services and well-known services, and it's great to be able to use that with bits of Moodle as well. And then finally, just a couple of points on databases. So you'll see here we've got a couple of different databases highlighted. So we've got Aurora, and we've got a session cache and a Moodle unified cache, MUC cache there. So with Moodle cache and session cache, they are typically, I think by default in Moodle, they're set to use a kind of file storage as cache, which would be local file storage on an instance in this case. You can probably see why that might not be a good thing here, because if instances are coming up and down and we have hundreds of them potentially, you're generating multiple copies of the same cache and it's not very efficient. And so Moodle has this concept of centralizing the cache store and centralizing session storage into really fast in-memory databases, and be that either Memcache or Redis. And when it comes to AWS, we have a service called Elasticache, which is a managed service and allows you to run Redis or Memcache engines in a managed fashion and have your application target them as kind of the Memcache or Redis endpoints. And that's what we've highlighted here. So what we've got here is a couple of different Elasticache instances or clusters, one for the Moodle cache and one for session cache. And what this allows you to do is in your Moodle configuration, all of your instances can target the same cache endpoints and effectively get access to the same cache. So you don't duplicate sessions, for example, or you don't unnecessarily duplicate the same or generate the same cache for the same content because it's all centralized. So that's definitely a key part of this, I think, and a way to help scaling, really. And then finally, on the Aurora piece there, so we've used Aurora in the diagram, which is part of our relational database service family. And Aurora is, I won't touch on this too much because Mark's going to dive into this, but Aurora is a Postgres or MySQL compatible version of RDS in effect. And what we've done with Aurora here at AWS is effectively change the way that the storage subsystem works. So we've effectively separated out the storage subsystem from the compute system, i.e. the thing that's running the database engine. And what this allows us to do is get greater scalability and greater throughput potential in what are the very commonly used database engines, open source database engines. So it's a great use case for something like Moodle, which typically uses open source database engines. Because you're potentially going to see a higher throughput, potentially be able to run a slightly smaller cluster than you otherwise would be able to because of these increased efficiencies, meaning you're saving some costs there as well. So it's a great option for this kind of thing. That said, we do obviously have customers that are running different database engines with Moodle, some of the more proprietary ones, and RDS supports those too. So RDS will support MySQL, Postgres, MariaDB, Oracle database, and also Microsoft SQL. And so if they are things that you need to use as well, then you could just use the relational database service, which again is a completely managed database engine, database service rather, for those database engines. And it means that you still don't have to manage or have the overhead of managing your own database engine. So it's still a really nice way to manage databases going forward. And the way that kind of helps benefit you as the team looking after Moodle is you no longer have to worry about managing the whole database stack, or maybe the NFS storage, or maybe the caching layer. All of those different services are now managed for you, and so you can really focus on optimizing the application itself and ultimately better serving your customers or your students or whoever it may be. So I think that's a great way to think about these managed services and how to take best use of them, really. So with that, I definitely want to introduce kind of Alex and Mark into the discussion. So I guess, Alex, Mark, any observations or any comments on this, or anything kind of to add on that?
Not from my side. I think I'll talk mostly about the connectivity side of things.
Yeah, I mean, nothing to add now, Stephen. You referenced performance and scalability capabilities of Aurora, and hopefully we'll come into a lot more detail on that later to illustrate some of the real benefits of that for Moodle as well. So.
Yeah, awesome. Thank you, guys. So with that, then I'll kind of hand over to Alex to talk a bit more about the networking side of things. As you can see, I kind of brushed over that a little bit here, but Alex is going to talk about this in the kind of the frame of in the university light, I guess, and where that kind of connectivity piece might come in, and where that might slot into something like Moodle. So with that, I'll kind of hand over to Alex.
Okay, thanks, Stephen. So I'm going to talk a little bit about different ways of integrating Moodle with third-party services, and that obviously depends on the connectivity depends on where those services are hosted. So either they're out in cyberspace, which could be out here in cloud, in the internet, or on premises. And I think it's important to make that distinction, as it can have a bearing on the architecture for your environment. So I'm going to cover this in broader terms rather than concentrating specifically on Moodle, as you'll likely have more than just Moodle running in AWS. So let's assume for a second that you have an S3 repository and Moodle needs to access an S3 bucket. So beyond setting up an appropriate IAM permission and roles, you also need to make a connection to it. Well, let's think about where S3 is hosted. Well, the obvious answer is in AWS, but where in AWS? So it's hosted in so-called AWS public zone, which means that it's publicly accessible from the internet. And it's using one of the regional S3 endpoints. So in this case, it's S3 EU West to AmazonAWS.com. So what does that mean in terms of connectivity to that bucket from within AWS, so where Moodle is located? So in order to connect to the bucket, one of the more obvious ways to do this is to do this from your EC2 instance, is to go out via the NAT gateway, which would then go out via internet gateway and then route the traffic to the internet and back into an S3 endpoint. Now, because both the internet gateway and the S3 buckets are hosted in AWS, the network packets don't actually leave AWS network. So the latency issues that are associated with normal internet traffic are kind of not there, but you still have those extra hops and the extra bandwidth charges that are associated with the NAT gateway. And that can actually add up to your cost there if you have a lot of data in S3. And also the internet connectivity requirement looks a little over the top to me if you just need to connect to S3 and nothing else. It's not normally the case, but let's assume that is the case. But happily, there is a less obvious way, and I say it's less obvious. It just doesn't seem to be as well known as just going out via the internet and connecting back. And that's something called VPC endpoints. So what VPC endpoints do is, in case of S3, is add a prefix list to your subnet route table from the subnet where the Moodle is directly to S3. So that means you don't actually need any internet connectivity on your instances at all. And what's more, with S3 endpoint and DynamoDB, it doesn't actually cost anything at all. So you're not paying for the bandwidth charges that would normally be associated with NAT gateway. And VPC endpoints can actually be used for more than just S3 and DynamoDB. There's a list of services on the AWS website if you're interested. But do be aware that there are charges associated with those endpoints because of the way they work. They work a bit differently from how S3. So with VPC endpoints, you can control what actually goes through them. And it's a little beyond the topic that we're discussing here, but each VPC endpoint can have a policy that allows specific principles. So that would be your IAM users or roles that can access it. So in our case here, it would be the IAM role that's attached to the Moodle instances. So they would be allowed to connect to that VPC endpoint, which would then connect to S3. And you can also add restrictions to the S3 bucket itself. So that can have a statement that says, if the requests are coming in from a specific VPC endpoint, so this one here, then let them in. So endpoints kind of also give you that additional layer of security, and it makes the bucket sort of truly private. Okay, so let's go back to Moodle for a second. So let's assume that your instances need to integrate with a publicly facing API. So that could either be a service that you're hosting on premise or exposing it to the internet from on premise. So that could perhaps be because you're integrating with something other than Moodle. Or your Moodle can be integrating with a service that's hosted by a third party. So in either case, you will still need internet access. But I would still highly recommend using the VPC endpoints for services from within AWS rather than going out into the internet and going back in. Okay, so what about services hosted on-premise but are not publicly accessible? Well, you'll need a VPN connection between AWS and your on-prem. So VPN itself is quite a big topic, and there are many ways to configure it, and that really depends on your requirements. But in its simplest form, it's a connection between your on-premise and AWS. So your on-premise customer gateway could be your switch, it's Cisco, Juniper, F5, anything like that. And the AWS is a VPN gateway. So in this diagram here, the termination point is at VPC. So you can only connect, in this case, to this particular VPC via this VPN. So let's just take a closer look at this VPN tunnel here. So you'll notice that there are two tunnels. So that means the connection is highly available. So if one of these tunnels goes down, then the other one will continue working and it will still be available. So in the case here, it's not truly redundant as you only have a single customer gateway. So if this fails, then your VPN tunnel will fail because these two endpoints on the VPN gateway will have nothing to connect to at the back of it. So to make it truly redundant, you'll need another gateway on premises to fall back to. So that's shown in this diagram. So it's pretty much the same architecture, but you just have a second customer gateway. So whether this is really required, it kind of depends on your on-premise setup. Ideally, you'd want two customer gateways to be in two different locations connected to two different internet providers. Because if you have, for example, two switches in the same rack and that rack catches fire, well, that's not going to help. So as I mentioned earlier, this architecture allows connectivity to a single VPC. And if you wanted to connect to another VPC from the same location, you would need to create another VPN connection. And that's because you cannot route traffic through a VPC into another VPC. A VPC is non-transitive. So in the past, there were several solutions most of which relied on a network appliance, which was basically a piece of software which ran on an EC2 instance in AWS, and it acted like a traditional switch. So it worked, but it wasn't the most elegant solution. So there's a new kid on the block now, and that's Transit Gateway. And I say it's new, it's been around since late 2018. And in my opinion, it's a real game changer in how network topology can be designed, or how networks can be designed in AWS and between your on-premise. So your hybrid network topology will be different from how it would normally be set up. So what Transit Gateway does, it allows you to create a hub and spoke type network, with the Transit Gateway being the hub, and all the other connections to it would be the spokes. So in our case here, instead of terminating, the VPN at VPC, you would be terminating it at Transit Gateway. And then you would use the route tables that are attached to Transit Gateway, so you can see it in the screenshot here, to divert traffic or to route traffic from VPN to a required VPC. So for example, at the bottom here, we have a VPN connection from this IP address. And then any packets that are destined to these CIDR ranges would be forwarded to their respective VPCs. And that's all coming in from a single VPN, or either a single or double VPN connection, depending on your setup. But that's your kind of recommended setup if you have multiple VPCs or even multiple accounts in multiple regions that you need to connect back to on-premise. So the way it works is that each VPC would have a Transit Gateway attachment, and the Transit Gateway attachment is just an ENI. It's an Elastic Network Interface that the traffic is sent to. So it's almost like having an old appliance in your VPC in the old days. So if you have several Moodle environments, or if you have test, development, QA, whatever, they can all be reached via the same VPN through Transit Gateway. And this gateway, the Transit Gateway, can be used for more than just VPN sharing. You can use it to share your direct connect connection, and you can also use it to connect to other Transit Gateways, which could be in other regions. So it becomes quite a powerful tool, especially with multi-region on-premise sites. And I'm kind of barely scratching the surface with what Transit Gateway can do, but it's definitely something you should consider when you design your hybrid network, especially if you have multiple sites. Okay, so that brings me on to Direct Connect. So one of the most common questions we get from our education and research customers is whether they actually need Direct Connect. And to answer that, well, let's consider how connections are made from AWS, to AWS from on-premise. So in this quite basic diagram, you've got on-premise users connecting to AWS via the big internet cloud. Now, whether you have VPN to AWS or not is kind of irrelevant in this case, because your traffic will still be traversing the internet. And that can be quite unpredictable. You know, you've got all these squiggly lines here. You just cannot control what connection point your network packets will go through. So that will have an impact on your latency and bandwidth, and it will also be variation. You know, it'll be, you can't predict it. It'll be very different from day to day. So the further away you are from the AWS region, the higher the latency and generally lower the speeds. So how does Direct Connect help you? Well, instead of traffic going, go back, instead of traffic going via your internet provider, it goes directly to Direct Connect location. So the location is this, the X location is likely to be a telco house, so it could be something like Equinix or Telehouse. And that's literally where a cable from your on-premises network to AWS network is connected. So it's going to be patched from one switch to another. So it will not be going via the internet at all. So you're bypassing it. And so what that means is you're getting guaranteed, pretty much guaranteed speed and pretty much guaranteed latency, because there's no variation like you see here. It's not perfect. The connection is not redundant by design. So if you need high availability with Direct Connect, you'll need a second one, preferably to a second Direct Connect location. So it would be another box here, and you'd be going to that and then back into AWS. It's also not encrypted. So if you need this pipe to be encrypted, you need to set up the VPN over it. So it would be like the previous diagram, but it would be going via Direct Connect line. Okay, so that's your typical customer. But what about the education and research organizations that are already part of NREN? So NREN is National Research and Education Network. So in the UK, it's JANET. In Europe, it depends on the country that you're in. But most of the NRENs, if not all of them, already have direct peering with AWS. So it's almost the same as having Direct Connect, but you're getting it for free because you're already part of NREN. So if you're part of education and research, or if you're part of NREN, the likelihood is that you do not need Direct Connect. The only reason you might want one is if you have very specific bandwidth requirements. So with a single VPN connection, you're limited to around 1.25 gigabits per second, which I think will be more than enough for pretty much any workload, especially Moodle. But I'd love to hear from you if you need more than 1.25 gigabits per second. And you can set up a second VPN tunnel as well and bond the two together, so you'll get double the bandwidth. So there are ways around it, so it's not necessarily a requirement to go with Direct Connect if you have especially high bandwidth requirements. So in 99% of the cases, we say you do not need it unless you have a specific requirement. And that kind of covers my part on the networking, and I'll pass it over to Mark.
Thanks, Alex. Just quickly before we pass to Mark, I've just got a question on the Direct Connect, and or more of a kind of something to add there. So you mentioned that, you know, with the Direct Connect, it's potentially a single point of failure, and if you want high availability, maybe create another one. I think quite a common pattern we see, and you might have seen it with your customers as well, is when a customer might have Direct Connect, but then also maybe a VPN as a backup, and so they're able to kind of you know, defer to the VPN should there be an issue with their Direct Connect, for example. Is that something that you see as well with the NREN type customers?
We do. I'll be honest, we don't have any NREN customers with Direct Connect. We do have non-NREN customers which have exactly that kind of setup. So they have a Direct Connect going from their location to, I think it's Equinix in Slough, and then into AWS, and they also have a separate VPN as a backup. The one thing that we try to make clear is that VPN is not going to be as fast and as performant if that Direct Connect connection goes down. but it is there, so it's not a total loss to your network.
Yeah, no, absolutely. And you're right with, in the case of Moodle, the way we typically see this kind of connectivity being required is for some of the things that you mentioned on your diagram there with, reporting or maybe authentication, for example, which typically don't require, vast amounts of bandwidth. So yeah, it's a great point. Cool, thank you very much, Alex. So yeah, I think with that, we'll hand over to Mark, and Mark can deep dive a little bit on Aurora and RDS.
Yeah, thanks, Stephen. So before we look in more detail as to how Amazon Aurora can help organizations running Moodle specifically, it's worth having a quick recap of main features and benefits. As a database built specifically for cloud, Aurora provides a highly performant, cost-optimized platform on which MySQL and Postgres workloads can run with minimal impact of migrating from traditional open source databases. Specifically on performance, Aurora is up to 5 times faster than standard MySQL and up to 3 times faster than standard Postgres databases, while still achieving 4 nines availability and fast automatic failover. It's also true to its cloud principles, allowing independent scalability of compute and storage, with both being able to scale up and down automatically based on utilization. As a managed service, it also reduces the need for administration, automatically managing backups and patching, as well as recovering from any instance or storage failures on your behalf. Specific to Moodle workloads, in a few minutes, we'll take a look at the benefits of using auto-scaling compute and storage with limited to no impact on your Moodle deployment or configuration, and all whilst relying on the native code base of Moodle. Before we look at these specific features, however, let's take a quick look at the high-level Aurora architecture. You will have heard Stephen talk earlier around how the storage and compute is decoupled, and we're going to look again at how those are broken apart. For data storage, Aurora replicates data 6 times across 3 different availability zones within a specific region, ensuring high resiliency from disk, server, or even data center failure. Data replication between copies of the data within the cluster volume itself typically take place within single-digit millisecond timeframes, ensuring consistency of the data within your application. In line with the first priority, and Stephen referred to that as job 0 previously, of any cloud environment, data can be encrypted at rest with no additional overhead and can support growth up to 128 terabytes per cluster. At the compute layer, Aurora defines one instance as the primary replica, which is responsible for all write workloads as well as read workloads. Up to 15 replicas can be used for read workloads, as well as to provide high availability from. Whilst compute and storage scales independently, crucially, all instances within a single region utilize the same underlying logical cluster volume. This provides highly performant storage and access to consistent data, whilst allowing high degree of scalability for read workloads. With the high-level architecture covered, we're going to perhaps here examine those specific benefits of using Aurora with an example workload running on Moodle. The timeline on this graph is deliberately omitted, as this pattern could be applied over a year, a week, or a day. For our example here, we're going to use a day, where this is a view of a starting baseline workload overnight, which significantly increases in the morning, and then decreases again over the afternoon, but has a minor spike in the early evening. This could equally be applied to workload over a term or a semester. In a traditional infrastructure deployment, the capacity would need to be provisioned for the database to provide not only the workload itself, but also typically a second underutilized node available for high availability purposes. Effective capacity utilization in this scenario would be at best 50%, and during off-peak may only be a single-digit percentage of the provisioned server capabilities. Using Amazon Aurora, we can make a number of changes that will help optimize the provision of capacity against utilization. Firstly, we provision a baseline capacity, enough to cover the off-peak workload, while still providing high availability. During higher load periods, we can automatically add additional capacity in order to support the higher, predominantly read-based workload of Moodle. By maximizing the offload of the read workload from the primary instance, we can also ensure that appropriate capacity is available for that instance to handle the write-based workloads. As the workload reduces, instances will automatically be scaled back in order to ensure cost-efficient capacity management of database resources within your environment. So whilst details of auto-scaling can be complex, the ability of Aurora to enable and configure this functionality are pretty minimal. The configuration can be set up using a few inputs within the console as shown here. It's also worth noting that whilst earlier I mentioned talking around how Aurora can automatically scale storage up and down, we've not talked about how to enable this functionality. That's because it's enabled by default and doesn't need any additional configuration to make use of it. Cluster volume will automatically grow in 10 GB increments up to that 128 terabytes limit per cluster. For compatible configurations, it will also automatically scale back down again on table or database drops or an optimize or vacuum statement. This enables you to run end of year or end of semester maintenance on Moodle without needing to complete additional time-consuming maintenance of the underlying infrastructure itself and achieve the highest correlation of cost efficiency. So the easiest way to benefit from Aurora's scalability and availability management is to make use of Aurora Endpoints. An endpoint on Aurora provides a listener or connection for your application to use in order to connect to the database. These endpoints automatically handle the availability management of your database, monitoring replicas to ensure that your application can always access your data. Should a replica fail or is being removed as part of scaling activities or patching activities, the endpoint will automatically redirect queries to an alternative replica without needing any endpoint updates within your application. This also applies to the primary instance, where in the event of failure or a patching event there, Aurora will transparently promote an alternative replica to be used as the primary for write workloads going forward. Aurora provides two main endpoints to be considered here, namely a cluster endpoint, which handles both reads as well as write workload, and secondly, a reader endpoint, which only handles read workloads. In the screenshot to the right, you can see both available in this example deployment across 3 instances. If we switch back to looking at the architecture view of how this scaling works with the endpoints, we see here an Aurora cluster with 2 instances deployed. This could be, for example, our overnight baseline workload. The cluster endpoints show the primary instance in both the cluster and the reader endpoints, but the replica is only within the reader endpoint. As in the example where workload requirements scale up in the morning, we can see additional replicas being added in, and that the additional replicas are automatically included into the reader endpoint. By using these managed endpoints, applications do not need to handle connection management themselves, allowing Aurora to ensure the most efficient use of resources and manage transparent scaling on Moodle's behalf as the application workload changes. So we've talked about how to enable Aurora infrastructure to support highly scalable workloads, but let's now look at how to deploy this into your Moodle environment. To illustrate just how easy it is to make this configuration within Moodle, from version 3.9 onwards, you can set this up within the configuration file itself. And you can see on the screen here an example using the release config file. The reader and cluster endpoints that we discussed earlier on and can be found in the portal can both be used within this file, specifically with the reader endpoint being used for the Moodle slave configuration section as shown on the screen here. As you can see, it potentially only takes 2 or 3 additional settings to make use of this functionality of Aurora and introduce read-write splitting into your environment. So it's relatively easy to integrate Aurora into your deployment with minimal impact in order to achieve the key benefits of scalability and cost efficiency that we have mentioned. But I appreciate it's easy to say on paper that integrating is easy. Of course, it's necessary to test that before rolling out into a production environment. This is again where Aurora embraces cloud and compatibility principles, allowing easy importing and exporting of data using standardized tools such as MySQL dump and pgjump to enable the migration and testing path. Should you also be considering moving from other database systems such as Microsoft SQL or Oracle, tooling is available from AWS to assist and accelerate the migration, including the AWS Database Migration Service or the schema conversion tools. Once running an Aurora configuration, you can also use clone functionality to very quickly and very cost-effectively spin up additional environments for testing. Utilizing copy on write protocol, Aurora allows you to create a clone environment for multi-terabyte databases within minutes. It also does this without significant additional costs for storage, only incurring charges for the change data that you store. These cloned clusters can also make use of start-stop functionality to allow them to easily be shut down when not in use, whilst still maintaining the data that is used by the cluster. Aurora also continues to reduce the operational burden of the environment in the long term, amongst other things, automatically handling patching of the environment for minor version upgrades. It does so using replica-first patching in order to reduce impact to your application to around 5 seconds of reduced throughput, and allows you to also define the desired maintenance windows for these activities to take place in, such as during your off-peak workload times. It additionally manages continuous point-in-time backups of your database, allowing restoration to the second with up to 35-day retention of encrypted backups. Hopefully this brief deep dive into Aurora has given you an overview of how it can help you enable scalability of the infrastructure for your Moodle applications, whilst ensuring cost and management efficiency with minimal impact to your application workload and configuration. If you have questions, please feel free to raise them now using the Q&A function, and we'll make sure to be addressing those later on.
Thank you for that, Mark. I guess just a point on the wider RDS, in that I think what we've covered here is Aurora, and obviously I covered that a little bit earlier on in the main architecture review, and thanks for kind of diving into the Aurora specifics there. But I think just for the audience, it's worth bearing in mind that the rest of the RDS family, so the relational database service family with Microsoft SQL, Oracle, MariaDB, they also support many of the features that Mark touched on there. It's, as I say, it's not quite as it's not being built for kind of with a cloud first in mind like Aurora has, but some of the elements that Mark touched on there, for example, with backup retention and read replicas and those kind of things, they're all supported in those other database engines as well. So if that is a requirement for you for Moodle or otherwise, you can still take advantage of a lot of those features and functionality to kind of help with that, lower the management overhead for those kind of databases. So yeah, I just wanted to highlight that, but great overview. Thank you for that, Mark. Cool. So I think with that kind of brings us to the end of the content that we had to run through. Daniel, was there anything else you wanted to cover? I think you were kind of wrap up a little bit.
Yeah, we do have some questions from the audience first, so if you can handle that one. So the first question is, how do we handle new Moodle deployments or upgrades within the proposed environment?
Cool, thanks, Daniel. So I definitely welcome back Mark and Alex if you guys are still there, but I can kick that one off. So I think with Moodle deployments and upgrades, it's always a tricky one. This kind of application doesn't necessarily lend itself to kind of an auto-scaling environment. It's kind of used to being, I guess, kind of handled a little bit more delicately, certainly when it comes to upgrades. For example, you might need to upgrade application code independently of the database code. And if you can imagine in a scaling environment, that gets quite tricky. So I think one thing I would add there, and as I say, definitely keen to hear from Alex and Mark on this as well, but what I would add there is maybe consider both infrastructure as code to deploy your environments in the first case to increase that automation. But certainly from a deployment perspective, consider CI/CD tooling. Maybe you've got existing tooling already. AWS have a lot of native tools there to help things like code deploy, code pipeline, and code build, and so on, to really help automate that process. And what that can allow you to do is integrate steps to your deployment. So maybe roll out the application to instances, then perhaps do a database update, for example. And of course, all the while you're able to take, to Mark's point just then, snapshots of the database at different times to make sure you've got backups should anything go wrong during that kind of upgrade of the application. These are all things that might have been difficult to do on premises, but now you've got the flexibility to be able to do that once your application's in AWS. Hopefully that helps to answer the question, but keen to hear if Alex and Mark have anything to add on that.
No, I don't think so, Stephen. I think maybe perhaps just to add on to that point around the use of snapshots for the database specifically, we talked, or I believe we've all spoken around decoupling of the application layers. So being able to have those cloud ability to spin up short-lived environments that you can test a new database deployment into on test data before applying it, and then shut it down afterwards. You don't need hardware or compute capacity available, for example, to do that on running all the time. You can spin that up, give it a test, and then spin it back down again. So also reduces the risk of any application activities that you may be completing.
Yeah, absolutely. And I think just to finish off on that, when I mentioned infrastructure as code earlier, that kind of also helps with, to Mark's point there, with perhaps spinning up test environments a bit more dynamically and maybe shutting them down overnight or when they're not required, or even spinning them up on demand, for a specific deployment or a specific code change that you're trialing. It means that they're short-lived, you're only paying for what you need. It's the appropriate size for the task that you're undertaking. And so you really maximize the efficiency there.
Cool. Thanks for those answers. So let's take another one question from the audience. So what would be the recommendation for the migration of the existing Moodle?
Yeah, this is a really good question, and something that obviously all customers that I've spoken to in the space have kind of asked, and it's always the first point really. So I think this probably comes down to how customers are, or how people are running their Moodle environments at the moment. If they're running a containerized platform, the chances that they've probably already bundled up all of the application and dependencies and things in a container, and so deploying that in AWS on one of our container services, be that ECS, EKS, Fargate, it probably makes a little bit more sense to that type of customer because they've already packaged it up and they can bring their image along and kind of get quickly stood up with it. That obviously doesn't solve the database migration. Something that Mark touched on there is a tool of ours, a service of ours called DMS, Database Migration Service. That allows customers to do replication in effect from an on-premises or from a remote data source database into an RDS or Aurora database. It's also worth highlighting that many of the database engines in RDS and Aurora natively support logical replication, so the replication that's inbuilt within the database engine. So you don't necessarily need to use the database migration service to do this. If you're already familiar with setting up MySQL replication, for example, over a private network or something, to Alex's point on VPNs, you could definitely do that as well. Or, and again, this is an approach a lot of customers take given the kind of hours that a Moodle environment is typically in use. Some customers have opted to effectively take down their on-premises or their remote Moodle environment, take a copy or an image or a snapshot of their database, bring that into AWS and kind of stand up the whole thing in one go. And then obviously point everything at the new environment and kind of go from there. What I would encourage though is a lot of testing around that. And I think Mark touched on this a little bit. So definitely would encourage trying to do, take a snapshot of all of your data and an application ahead of time, get that stood up in a test environment, get it thoroughly tested, probably even load tested as well. That's something I wanted to touch on earlier and neglected to mention when I was talking about scaling. But tweaking and tuning those kind of parameters is really important, I think, and will make sure your journey to cloud for this kind of app is a smooth one. So definitely try and get something migrated in a test environment. I would strongly encourage you to consider load testing and performance testing whilst there, so that you can understand the performance capabilities and where you might need to tweak and tune configuration here and there, before ultimately then roll into production. And again, to bring us back full circle, that's where infrastructure as code can help in spinning up those multiple environments.
Cool, thanks, Stephen. So we are now at the end of our webinar, and I would like to also emphasize on the end of Stephen's answer is that with our partners, AWS is offering a number of different elements, a number of different ways to help you to evaluate the possibility of the migration of the Moodle. And we can do this through a number of different interactions and workshops. And also importantly to mention, our partners JISC and Rackspace are members and are delivering AWS services through OCRE framework. So OCRE Cloud Framework is the new framework conducted by GÉANT together with the NRENs in each and every country. And the important element here is also the connectivity and ability for you to procure cloud resources and professional services to help you with your migrations through that framework without need to conduct any public procurement procedures, and also includes number of different benefits like some of the discounts which you can get in the beginning through the framework. But for example, also we are offering global data egress waiver, which waives complete egress or 15% of the overall bill of egress if you are working and operating under the OCRE framework, which is also one of the tangible financial benefits. So if you are interested, feel free to reach out through the email that you are going to get as a follow-up, or we will be following up if you expressed already the interest during your registration. And we are looking forward to start discussions with you on how we can help moving your Moodle to a more resilient and more accessible state on AWS Cloud. So thank you very much and hope to see you again soon.